Welcome to a new lesson. In this lesson, we will be proving congruent triangles. Before we prove congruent triangles, we need to review the 4 general congruency laws. The first congruency law is side, side, side. That means if there are 2 triangles and all of the sides are corresponding to the opposite side in a triangle, therefore these 2 triangles will be congruent or equal in geometry. The next rule is side angle side, SAS. This means that if one side and then the angle next to the side is corresponding to the opposite triangle, as well as another side which is next to the angle as well, therefore those 2 triangles are congruent. Next law is angle side angle. That means if we have an angle, a side, and another angle next to that side, we have 2 congruent triangles. And the last rule is side angle angle. That means if we have one side and an angle and another angle that are corresponding to the same type of angles in the different triangle, then we also have a congruency. Therefore, all the sides and all the angles have to be equal in those 2 triangles. We're going to be using those 4 laws to solve next 4 triangles. Let's take a look at our next example. In this example, we'll prove that triangle ABC is congruent to triangle CDE. What's also given in this picture, there are some informations. What's given is that we know that there are sides that are equivalent. Angle AC is equal to CE, because that's what's given in the picture, as well as we know that side AB is parallel to CD. That's indicative by the one arrow on that line segment, as well as CB is parallel to ED, and that's also indicative by the 2 arrows on those 2 line segments, showing that they are parallel. So what we need to do is we have to show that these 2 triangles are congruent. Before we attempt this question, we need to kind of look at this diagram and figure out what can we find out through the information that's given to you. Can we find out any of the sides that are equal? Can we find out any of the other angles that are equal? And then if we can't find those things out, then we can solve the problem. Now it's important to identify the most important parts, such as the transversal and the parallel lines. So for example, before we even attempt this question, let's just draw the transversal and just pick some of the parallel lines like this. So I'm going to use green. What can you tell me about those angles? Are any of those angles equivalent? Well, since those are parallel lines, and this is the transversal, ignoring the blue lines, we can tell that these 2 angles right here, this angle and this angle is right here, because those make the letter F. Therefore, those 2 angles that look like this are corresponding angles. So we could prove that those angles are equivalent. And I'm going to leave those angles like this. So this is just sort of planning to see what can we prove. What else can we do? Let's take a look at the other parallel lines. And this time I will use a purple. Sorry, not purple, but orange color. So here you go. What else can we prove? Well, we could prove that these 2 angles right here are also equivalent or corresponding, is because we have that upside down F again, showing that if these are 2 parallel lines, these angles are also corresponding. So let's erase the parallel lines and leave those angles that we found out that are equivalent based on the parallel laws, and see what can we do to solve this problem. So here the 2 angles are equivalent, and so are these. So what congruent laws can we use to find out that these two triangles, mainly this one right here, ACB, and this one right here, are congruent? So what I would do is I would go back to my congruencies laws and find out which of them can I use. What does it look like? So here are the laws. Which of these do we have? Do we have SSS? Do we have SAS? Do we have ASA? Or do we have SAA? And we have ASA. This is what we have. So what we're going to do is we're going to use ASA to find that these two triangles are congruent. So this is just the step before we even start the problem. We are just sort of brainstorming or planning, and this is where we show our proof. We draw a table. So here is our table. We have statement on the left corner, or left column, and a reason on the right corner. So the first thing we're going to prove is one of the angles that is corresponding. So we said that this angle right here is corresponding to this angle right here. Now the difficult part about this is naming these angles. How do we name these angles? It's not going to be just angle A, and it's not going to be just angle C. Recall that naming angles in a triangle requires a beginning, a middle, and the end. So in this case, we're going to start with C. So we have angle C. The middle one, what we're really interested in, is A. It's called the vertex. And we finish at B. And that's equivalent to angle. Let's again name this angle C. We start at E, go with C, then go to D. So it's angle E, C, D. And the reason for it is because they are corresponding angles in parallel lines. So simply again, if you draw these angles again to show these parallel lines, so here's your two angles, here's your transversal, and here are your parallel lines, and it makes that F. The next part where we have to prove is the side. But which side? Well, it's this side right here. Side AC. So AC is equal to CE. And why is this equivalent? Because it was actually given to us in the problem. This is a previous information that we already knew when we had this picture. So it's given to us. We didn't have to prove it. It's just provided, so that we just stated it's given. The next thing we have to show is we have to show that the last angle is equivalent to they're equivalent to each other. And those angles were right here. And recall that this was the transversal, these were the parallel lines, and it made that F, the upside down F. So really these angles are pretty much equivalent or corresponding, the same reason as the previous angles were, the corresponding angles in a parallel lines. But now naming them is a little bit difficult. The bottom angle is CED, so CED is equal to, and the top angle is ACB, angle ACB. And the reason for it is because it's corresponding angles in parallel lines. So now we have answered angle, side, angle. That means we found that the angles, side, and angle are corresponding. And then at the very end, we could reiterate or rewrite or just copy that statement. Angle or triangle ABC is congruent to triangle CDE simply because of ASA. And this is a pretty good proof for our first congruency. Let's take a look at the next example. In this example, we'll be using reasoning with congruencies to prove that sides are equal. So we have two triangles, and what's given to us in this question, so we should always write that information on the picture, is that line segment TP is perpendicular to line segment AC. This is a perpendicular side. This means that not only that they are 90 degrees to each other, but also because the TP side is shared by two triangles. Also, it's given to us that AP is equivalent to PC. And so that's also, we have to indicate that in a triangle. What also is important is that we need to find out that TAC is isosceles. That's what we're trying to find out. And isosceles means that two sides are the same in a triangle, or two angles are the same. That's what isosceles means. A quick way that I remember about what isosceles identifies with is that I see with two eyes. I saw, I see, and therefore there are two angles or two sides involved in this triangle. So we have to basically prove that two sides or two angles are the same. The only way we could prove that is by finding that these two triangles right here, this one right there, and this one, are congruent. And once we found out that these two triangles are congruent, that's the only way to find out that two of the angles are going to be the same. And therefore, if two angles are the same, the triangle TAC is an isosceles triangle. So there are a little bit more steps just after proving congruencies. So what can we prove exactly? Let's in this problem. Well, we know that there is a side. We have a side, and we have a side as well, and we have an angle, and we have an angle. But SA is not enough for us to prove anything. Remember, we have to have SSS, SAS, ASA, or SAA to prove congruency triangles. So let's go back to see which of these maybe sides or angles that we're missing in this question. Remember, what there's a missing side, well, not really a missing side, but a shared side, and this side is right here. It's shared. TP is shared by both triangles. Since it's shared, it's the same thing. That means, really, we have another side to this triangle. We have SAS as our reason for congruencies. So our plan is to use these congruencies to solve for isosceles triangles, but in order to prove our congruencies, we have to show that it's SAS. So let's set up our table. So we know that we have to show SAS first. So first, the side. Okay, so what's the side? We know that AP is given to us as equal to CP. That's just given information in the question. Also, we know our angle. Now we have to watch the angle, that we are labeling it correctly. Start at A, go to P, and go to T. So angle APT is equal to CPT. Angle CPT. And the reason for it is because TP is perpendicular to AC. And therefore those two angles have to be perpendicular, 9 degrees, and equal to each other. And it's really also is given in the question, because sometimes even say it's given. The other one that's missing is the common side, TP, and we actually write this down. TP is equal to TP because it's common or shared side. Now we found out that we showed that the first side is corresponding side, done. The angle is also done because it's really given in the question, and the two line segments are perpendicular to each other. And the last side is shared. So we found out, we showed that these sides and angles are corresponding. Therefore, we could say that our triangle, TAP, so we start again naming our triangle. So TAP, there you go. So triangle TAP is congruent with TCP, because of SAS. Okay, so far so good, but we're not done yet. Remember, look what the proof is. The proof really is that we're trying to find isosceles triangle. Then we have to show that one of these pairs of angles are equal. Simply the A and the C is the same. Or we could just say, probably easier for us to say that TC is going to be congruent or corresponding to TA. And that's what we'll do. TA is equal to TC. They are corresponding sides. Corresponding in a congruent triangle. And the last thing we should write down, therefore, triangle TAC is isosceles because two sides are the same. The sides are equal. So the first one, you had to show that the two triangles are the same. Now we're going to use these triangles to show that the two of the sides are equal, and therefore, since two of these sides are equal, the large triangle is isosceles. We'll do one more problem. So given in this picture, AE and BD bisects each other at C. Bisects means divides by 2 equally. So AE and BD are bisecting. Therefore, this side, AC, is equivalent to CE, and CD is equivalent to BC. That's the definition of bisecting. Also, we know that AB is equal to ED. Okay, so AB is equal to DE. And what we're trying to prove is that angle A and angle E, simply this angle right here, are congruent, or not congruent, but corresponding, they're equal. The only way we could do that is by finding a congruency first. And just by looking at this picture, you can say that it is these two triangles have SSS as a congruency law. But also, you might not see this, is that these two angles right here are also called vertical angles. So you could actually prove this question by using SAS, the congruencies. And, well, what's easier, it's probably the SSS, and I'm going to use that to show that it's congruent, these two triangles. Then, once these are congruent triangles, I'll prove that angle A and angle E are equivalent, because if a triangle is congruent with another triangle, all the angles have to be corresponding, and angle A and angle E are corresponding to each other. So this is the type of plan you should have before you attempt these congruency problems. So I'm going to set up a table first. So here's your picture. I'm just going to have the statements to show that it's going to be SSS. So first we have, be careful, AC is equal to CE. And it's really given in the question, bisecting. Therefore, we continue on. We have BC is equal to CD. And also given, really, it's bisecting. And then AB is equivalent to ED. That's really given in the questions right here. Therefore, we could say that triangle ACB is congruent to triangle EDC because of SSS. If I look at my picture, it's a little bit off. I have to take some wrong positions. We have 2 ticks, 2 ticks, 1 tick, 1 tick. Hopefully that didn't mess you up. And the last part will say that angle A is equal to angle E, simply because they're corresponding angles. In congruent triangles. And that little, that's just triangle. It's just a little shortcut, triangle, that I use. And here is the proof. So make sure you have a statement, make sure you have a reason, and make sure that you have a plan before you execute your proof. And take a look, is that your proof should be your last statement at the very end of the problem.